This lecture explains two types of errors that can emerge in hypothesis testing. And these are known as type 1 and type 2 errors. With type 1 errors, we make the mistake of saying that there is a relationship when there really isn't one. And with type 2 errors, we make the mistake of saying that there's not a relationship when there really is one in the population. So I'm going to go through this and explain once again with our example from the clinical flu vaccine trial. So imagine, again, you have this pharmaceutical company running a flu vaccine, 50 people treatment group, 50 people in the control group. And you have a difference where more people who are in the treatment group do better, that people who are in the control group are more likely to get the flu, right? So you're asking, is the flu vaccine effective? So reviewing once again, the hypotheses that we have, the null hypothesis would be that those receiving the flu vaccine are just as likely to get the flu as those who don't receive the vaccine. In other words, no impact, right? There's no relationship between getting a vaccine and getting the flu. And the alternative hypothesis is that those who receive the vaccine will be less likely to get the flu than those who didn't. Okay, so the question here is whether we are going to reject or fail to reject the null hypothesis based on our sample data. And then if we reject it, was that indeed the right decision based on what's actually happening in the real world? Or if we failed to reject it, was that the right decision based on what we have in the real world? So type 1 and type 2 errors. So I'm going to want you to write out this table that I'm going through, and I'm going to talk about each cell bit by bit. So imagine just hypothetically that we could know in the real world, in the entire population, the real effect of the drug, right? We don't actually know this because we're researchers, and we can only sample, but just imagine, this is God. God knows this. So there can be two scenarios in the real world. One, that the drug has no effect, and this would be that the null hypothesis is indeed true, right? That if you observe that there's no relationship, that's because there is no relationship. So the drug has really no effect. Alternately, the drug could have an effect, in which case the null hypothesis would be false, right? So these two columns here are going to be the underlying real world that we see. And then here, the rows will be what we actually observe in the data, right? So the top row would be that the drug in our sample has no effect. That's what we see, that there is no relationship. And in this case, we're going to fail to reject the null hypothesis, that you see that the treatment and control groups are basically equivalent. Alternately, you could reject the null hypothesis, that you say that the drug does indeed have an effect, and you are seeing that difference in your sample. Okay, so here you're saying, based on your data that you collect, that you believe that there is no effect. Here, based on your data, you believe that there is an effect. So just again, this is the underlying real world, this is the population, and here is what we are observing in our sample. So the question is how these two combine. So first one is a correct decision, which is that in the real world, there is no effect from the drug, and in our data, there's no effect from the drug. So this is the right decision. We are effectively saying, no, there's no relationship, and we got that right. But you can also imagine a type 1 error, which is in which that there is really no effect from the drug, but that our data show that there was some sort of difference, and we made a conclusion, yes, this drug vaccine is effective. We should mass market it. We should get it out there. We're going to make sure that everyone receives this vaccine. And really, that was just by chance that we saw that relationship in the data. The null hypothesis was indeed true. There is no real relationship between getting the vaccine and getting the flu. So in this case, we made the incorrect decision, and this is called a type 1 error. And just as a note, we tend to be most concerned with type 1 errors in statistics. Another kind of correct decision would be, if in the real world the drug does have an effect, the null hypothesis is false, and then we conclude the null hypothesis is false based on our sample. So the drug really does have an impact. We see that in our data, we make that conclusion, and we were right? So this is good. We're happy with this result. But a type 2 error would be one in which the drug does really have an effect, but we're not able to actually conclude that that wasn't just due to chance. That when we looked at our data, that the effect was too small, and we weren't able to reject the null hypothesis. This is a mistake. This is an error. The drug really was making a difference, but we weren't able to capture that with our data analysis. So these are the two types of errors that we see. So overall, we see that both type 1 and type 2 errors lead us to make incorrect conclusions from our data. And as I mentioned a little bit earlier, we have set up statistics to reduce type 1 errors as much as possible, because we need to be really cautious if we're claiming that there is some sort of relationship in the data. We are setting up statistics to be very skeptical, right, to not make type 1 errors. And this is balanced out often with researchers' own desire to reduce type 2 errors. You're not going to get a paper published if you say, well, there was no effect. Right? That's not something that usually results in a publication. And so this pushes people to try to increase their sample size enough so that they're able to make the correct inferences.